We'll talk about external entity attacks. What are XML entities and what are external entities? The standard itself spends pages describing this topic, and you can briefly sum it up as follows. These are actually variables declared in the DTD and used in the XML body. XML entity offers more in the sense that it can actually pull in variable content from external sources like HTML or something else. The easiest way to utilize it is like this. If you have an application, it processes in XML and obviously and returns the XML contents to the user, then we are able to read files. I promise that we'll not deal with the web, but this is still a PHP-based applications for the purposes of a mini demo. Let me show you here that here we declare a variable with a value. We substitute this into this location, and when we process it, we see that the contents of that variable have actually been injected into the body. This only shows you how the entity itself works. What is more important is the external entity. We similarly set up a variable, but pull in the value from an external file. I'm showing you that external file. This is the contents of that external file, and if we get it processed, then we see that the contents of the external variable is actually inserted here. We use the file protocol handlers. File and HTTP are the two most frequent ones that are known by XML parsers. There are some others. Java has the jar protocol handler. Also for Java, if you specify a directory, then you receive a directory list back. And PHP has the PHP protocol handler, where, well, if you have ever executed web-based attacks, you may know about this from local file inclusions. There's a base64 encoding filter which works just the same for XXL. Let me show this to you. Here we have the variable once again. I compiled a URI that uses the base64 encode filter, and XXL PHP source will be returned by it in base64 encoding. Here we see it, we have received it, and if we decode it, well, this is the base64 stream, and if I decode it, I receive back the PHP source. Well, that's my part. I'd like to pass the mic to Ákos. Thank you, and welcome everybody. I was a bit afraid what we would run into when swapping laptops. We're talking about parameter entities. What document entities can be used in the body of the XML, and we can evaluate it. What are parameter entities good for? Primarily, you will note that instead of the usual MVM, usual ampersand, we'll use percent sign for declarations. In addition to the syntax change, what is more important is that the form is much more free. So these variables will be freely replaced by the DTD interpreter. So we do not have to adhere to XML syntax in our stored information. It's enough if it is DTD conformant. These are the two entities that we need to pay attention to. ampersand and percent to be at the right places. Also, we can also reference these things from external files. So we have more freedom through this if you want to do something dirty. Let's have a look at this demo. Here is my colleague's application that is once again web-based. True to our promise not to deal with web-based things, it loads the variable and reads the part between the tags. We have already seen file inclusion, where we'd like to display the password on this website. Nothing happens. This could be a demo effect, but let's look at what is happening in the background. This is the log of my Apache server, and it is full of error messages issued by the XML parser. This is because there is a special character in my SVD password file, and when it tried to display it, then the XML parser ran into an error. How can these parameter entities help us? We have a CData part in XML. Content in CData will not be interpreted by XML. Instead, it will handle it as a comment, and it will leave and print out all characters in CData unchanged. Let's look at the XML file that I compiled for a test. We have a root, we have a start tag, which is a parameter entity. You see the percent sign there. And this parameter entity describes an CData open tag. We have a closing tag, N, which is the closure of the CData part. And we have a system variable that reads the FS tab file in this case from the system. That's nice and good, but what will happen? We have an external DTD referenced here, and its content is of importance because we can actually use the tags, and you can concatenate the tags and the file contents that we have read in and make it a variable called all. Let's look at this in practice. My SVD passwd file is being read in, which we could not do before. And we see the CData tags. And if we look at it, the output, this is the contents of the DTD. If we load it, we see my etc passwd file, so CData embedding works. The next technique is an out-of-bounds technique. In this case, we once again read an external file from the local machine, but we'll read a file from the local PC, but we'll try to use an external parameter entity to send it to a third party, which obviously can work through multiple protocols that it can handle. It can be FTP, HTTP, or file protocol. All of them may be of different implementations. We compiled a demo that includes a domain controller, a microcontroller, we have a domain controller running Windows 7. Between the two, we interpret a group policy preferences setting. If somebody doesn't know what group policy preferences is, it is used for centrally send scheduled tasks to clients in the domain. We use a sharing on sysvol that DC can communicate with, and it will put these XML files on the sysvol containing these settings. But these can be read by any domain user, and they include the password that is needed by the client, and it is there in an encrypted form. So we will now open a Visual Studio. The project includes the XML file that will send the scheduled task XML to the attacker who is expecting it on port 4444. This is our Windows 7 with Visual Studio 2012 on it. How this project got on the user's machine and what prompted him to open it, well, it's up to your fantasy, up to your imagination, but Visual Studio has the useful feature that if even a very small change occurs, the XML will be reinterpreted. I just hit an enter, and the XML has been reinterpreted, and its content has been sent to the attacker. So what we see here, you see the scheduled task.xml in encoded form that you wanted to receive, and if you have a good eye, you will notice that here is the admin user and the assigned password in the C password attribute. This is the encrypted password, and luckily Metasploit enabled us to decrypt this password. We have a C password Ruby-based application here that is running. That'll think a while and then spit out the password, which is Hacktivity 2014. Let's check quickly whether it really works. I RDP'd it to the domain controller. And after entering the appropriate password, we see that it does in fact work, so we were able to enter the domain controller as a domain admin. That was the demo. And I give the mic back to my colleague. Right, so we could see that a simple external entity attack can be used to do interesting things. What happens if we pursue it a little further and combine it with other attack methods? We saw that we can send HTTP or FTP requests to servers. Let's use it for the inter-protocol exploitation thing. We have a protocol that we can use to talk. Another service is also used for speech purposes we'd like to actually crack or hack into. This is feasible if the protocol to hack fits the one that we are talking through, and if the server that we want to hack into is fault tolerant enough to swallow the first protocol's peculiarities. For instance, if we have, if we want to crack to hack into an FTP server through HTTP communication, then the HTTP communication part must be swallowed or allowed by the FTP server. This is often the case and can be utilized. If we combine this with XXE, the biggest difficulty is that XML parsers pretty much limit the usable character set. We checked a few XML parsers for the characters they allow in the URL. Visual Studio accepts everything, but encodes all characters in URL. Internet Explorer only accepts characters lower than 7F, and some of them, including space, are coded in URL, and it also drops new lines. So you cannot use this for text-based protocols. In order to show you this trigger BOF via XXE, I show you a classical buffer overflow rewrite using on an FTP server. The attack will be as follows. We have a hacker who creates an appropriate XML file, sends it to an exist DB database admin, who will upload the file for some reason to the database. In the database, the XML file is interpreted, the external entity gets called, and an HTTP request is sent to the FTP server, which will then trigger the exploit, and on the PC on the FTP server, we will see a calculator appearing as the result of the exploit. What were the difficulties? Well, for one, we can only use alphanumeric shellcode. We can also use UTF-8, which will make it easier. In generating the shellcode, Metasploit was of help. There's an alpha mix and alpha upware encoder, and we also have buffer register, allow Win32 SEH default options that are useful. These allow us to create shellcodes consisting of purely ASCII characters. This is the shellcode that we crafted. It's actually a Windows exec payload that is being generated. Here we see that this only contains printable ASCII characters. Then there's only one more problem. We somehow need to get to the shellcode, so we need a jump ESP that has an ASCII-only address. You can use Mona, only debug, or whatever to find such a place. And you found one in user32 DLL. And I use this to put this demo together. This is the XML file that the attacker will send. You see that an HTTP request is being sent to a local address on port 21, excuse me, which is the PCMan FTP server. The lots of A letters trigger the exploit, and you see the jump is ESP and the shellcode itself at the end. So if we upload this XML to the database, oh, it logged me out. Let's log in again. So upload, and the FTP server actually did display the calculator that is the result of the exploit. It's my colleague's turn once again. Well, I can hardly wait to see the wireless world coming. Okay, now that Calculator X has received the well-deserved round of applause, let's look at another demo. It will be somewhat different. Let's first check what is going to happen. We have an application, the Garmin Training Center, where you can upload GPX files from richer people's machines and collect them into a single location. Let's quickly import our latest cycle tour, and we will see that although we have rolled a lot, but not that much, it probably froze. Let's look at a webmail user interface. I hope it won't log me out. This is the user admin's account on Postfix, and all of a sudden we have received an email. Let's look at what happened in the background. we had the initial demo I wanted to put together. I'll tell you what I wanted it to look like, and then I'll show you what actually became of it. Well, there is a Pigeon installed on this Windows 7 client, and we have this Garmin application. Let's look at what happens. These are the actors. We open the GPX file for import, and when it is opened, the GPX file includes an XML that will send the parameter entity. It will use the parameter entity to send to my attacker the Pigeon settings file that includes information in unencrypted plaintext form, and it's a valid XML file. Once this has been sent, the attacker will think a little and then generate a payload based on the account information included in the message received, and creates a DTD descriptor that he will send back to the client. And after this has been run by the client, an SMTP request will be generated. Real SMTP traffic will be generated, obviously, through the HTTP protocol handler, but it will go to the SMTP server. And this will enable us to impersonate the target and log in through SMTP to somebody else's account, for instance, the administrator's account, who is the postmaster. And this is what I wanted to show you at the demo. But what happened? I got a red line here, which means that separately both parts work as expected. The GPX file is sent and the response is returned as expected, but the two do not interoperate. Let's still look at what happened in the background for you to clearly see what happened. This is the email. The email can contain anything. Obviously, you will need to think up some sort of social engineering text that will prompt the user to do what is expected to do. So we received the email. What happened in the background? Our Garmin is still frozen, is still waiting for response. In the background was running, we saw a shell was running, and you see the communication on it. Let's look at the communication with the attacker. The client started a request for the payload. This is the part that is not a generated payload, but a static one. And here you see that it creates an entity it starts an HTTP request to the SMTP server's SMTP port, and the other remaining parts of the HTTP request are included in this SMTP protocol containing the actual commands. Here's the welcome and the login and the other parts of the message, and it's also the connection is closed. And it's important that we call this parameter entity, so the whole DTD that we could put together will get evaluated, and this will be evaluated on the client side. Let's look at this part as well. This is the SMTP communication, the communication with the SMTP server. Here you see that the client tried to get pad. This is an HTTP request. But then it received, our request was sent to the SMTP server, which at first did not recognize the get command, which is normal. But then, because this protocol is a fault-reliant one, you can even send trash to the SMTP server; it won't reject us. So we were able to have our actual request run, which resulted in the email being sent. And finally, we received some head shaking about bad syntax, because we also tried to send an HTTP and the post syntax. This was the background communication. And I'd like to say a few words in addition. As mentioned, this demo did not actually run as a whole, however hard I tried. Why did we choose Garmin Center as the application? Well, it has a very nice property. It does not drop new line characters. The passes them on. This is why the async communication could be carried on because \n is needed there. What is not working in Garmin Center, it could be an implementation fault. The protocol description seems to say that this replacement should actually work, but it doesn't. We couldn't put this document entity into the message and have it evaluated by the interpreter, so this is why I couldn't send the pigeon settings file and then add the DTD to it. But on the other end, Visual Studio 2012 works nicely in the respect that this parameter evaluation works as expected, which enabled us to steal a file from Visual Studio in my previous demo. But one of its big cons is that it's a great fan of URL encoding, so it also encodes parent characters in URL, so SMB communication will not work. This means that we can solve this attack with one application and two GPX files. The question is whether this will stay as problematic as it currently is. I have not yet relinquished hope for it to work together with Garmin because I remember I've seen it work once, but then I refined my demo to a point where the state got lost. I have not given up on Garmin either, and there are probably other applications that actually pass on \n characters and also allow Visual Studio feature to be used there. In Visual Studio, we have an entity which sends to the attacker's IP address the value of this all variable containing our file that we have read in. And this functionality actually works, and it's also important that it also returns within the DTD, which means that in the return information we can specify another DTD structure, which will enable us to control Visual Studio, sending it new and new DTDs at every turn dynamically, which all can result in additional attacks until Visual Studio server will just say, I won't take any more of it and stop working. It is very easy for the attacker. If we could put the two together, that would result in a perfect tool. So we do not give up on this. It'll get better, I promise. And this is the last part we'd like to talk about. There was this idea to have a look at what various virus scanners say to docx, which is a zipped file with a lot of XML in it. Well, this was the basic idea. We grabbed in Tamas source on the string XML, and it turned out that libxml2 is used for XAR archive scanning. XAR is a compressed format that contains XML data. We wanted to know what other antivirus software know about these formats, so we picked the ACAR string, which is a standard virus, and we compressed it, XR'd it, and sent it to VirusTotal. And in addition to ClamAV, these are the antivirus software that actually can deal with XAR. We have checked which XML parsers they each use and whether they can be attacked, and it turned out that it is only ClamAV that might be prone to attacks. So we tried to break ClamAV, to break into ClamAV. Let's have a look at the XAR format. We have a header with all kinds of information about the file. We have the XML metadata, which is actually compressed in the file. These colored bits are the header, the size, the XML metadata, and the orange at the bottom is the compressed actual data. This is the insides of an XAR file. What did we do? We used a Python script to create XAR files containing XML metadata that we put together ourselves. The first attempt we did was to put this XML in the XR file. The XML contains an XML entity. All it does is it connects to the local host port 8080, the HTTP port. The HTTP port. So we compressed this, we created this file, we scanned it with conscan, and we received the correction back, which showed that the thing is going to work. This was actually a proof of concept, but what we wanted to do was to execute remote code execution, RCE. What were the difficulties that we encountered? I mentioned that libxml2 is used by ClamAV. libxml2 is does very strict checks for the specified URI. It actually fully corresponds to the standard, to the RFC, and the greatest limitation that it meant was that it drops new lines. It does not align new lines. So out-of-bound attack can only be used in a limited form because the only thing that we can run is single-line files, which does not bring much to the kitchen, does it? Thinking along these lines, we came on the idea that we actually create HTTP requests. Let's execute a server-side request forgery, SSRF. So we are actually sending HTTP requests to another server. Here we also run into limitations. We can only use GET requests. We can only use HTTP. So libxml2's HTTP protocol handler does not handle HTTPS, and the payload can only contain ASCII characters. I wanted to we wanted to find out how successful we could be, so I picked the HTTP bits of a exploit, and I filtered them to not use post and SSL. This returned a function list of roughly 90, which I actually sorted manually to get the ones that do not contain characters that I cannot send, and also does meet other requirements, and I ended up with an exploit list of roughly 42 that we can use for this attack. I didn't try each of them, but they probably would work all. The free PBX exploit was used for our demonstration. It is a relatively fresh exploit that appeared in March this year, and so if it is parameterized appropriately, then it enables us to run a command. And this is what we'll do through NXC. We have the hacker who creates an XAR file. We have an email server that is running ClamAV. So ClamAV checks all incoming emails, and our hacker will send this XAR files in an email through the email server. ClamAV will check it, which will then get the XXC part processed. The HTTP request goes to the PBX server. The HTTP request runs a command that links back to the attacker. So the attacker can run commands on the PBX server. Now, what does it look like in practice? These are the computers. This is not that interesting. Let me show you first what happens if I send this string to the mail server. It responds by saying it's probably a malware, so it will not forward the email. So the email server ClamAV virus server combo does in fact work. This is the Python script that I used to create the XAR file, and this is the XAR that I'm going to send. I have an external entity here, and this is the HTTP request that will get sent to the PBX server. Okay, this is the command that creates a pots.xar file that we send. It has already been prepared into the MT. So you can see that it is sent to the server, and in attachment you see the pots.xar file, and if everything goes well, here we will see the connect back shell. I hit send, and we actually see the connection loop back to us. So we can issue commands, and we actually now own the free PBX server. And that was it, guys and gals. We have a couple of more minutes, so let me say a few words about how to continue this research. The original topics that we started out from are still valid, so it's worth having a look at the games. There are some games that use XML for saving games and network communication. It's well worth checking out. There's this Airways XML metadata bit that can be embedded into multiple file formats like PDF or PNG. So it's also worth checking out with a sharper eye. And sometimes we do not work with text-based XML. We also have binary XML formats, of which we also have quite a number. We did not have the time to check all these out, but we do think they are worth the investigation. And also we have the netconf protocol used by multiple firewalls for remote configuration. And obviously there are the XML databases. IBM, Oracle, SQL all have XML databases and the multiple smaller databases. In one of the demos showed an Access database, which is also an XML-based database. And that's it. Thank you.